I am Sanjay Bhardwaj from Department of Computer Science and Applications, DAV College for Girls, Jamnanagar. The topic of discussion of this lecture is classes and objects. By this time, we are familiar with classes and objects. In the last lecture, we discussed how the classes can be declared, how the member functions of the classes are defined, how the objects are created, and how objects assess the member functions. In this lecture, we will discuss all these things with the help of one example. We will be implementing a class for complex type data. Now, complex numbers, as we know, are the combination of two real numbers. These are represented a real part plus eta and imaginary part. We will create a class for this, and this class will be having the data members and the operations that can be performed on these complex numbers. This lecture will start with just discussing the class or designing the class. Now if I say class for complex number. Now if I say class for complex number, we understand that class is basically combination of data members and the operations to be performed on those data members. Now say the data members in this particular class are, first is the real part and the second is the imaginary part. These two will be data members of this particular class. Now I say the operations. The operations of the class are given in the form of member functions. We can take number of member functions as per the requirement. For this example, I will be taking the operations, say input of the complex number, and I say the function get number. This will be a member function that is used to input the complex number. The next I say printing of this complex number. Say the function is now put number. The next one, addition of two complex numbers. I say the function is add. This is addition of two complex number. Another one can be copying one complex number to another, and the function I can use is copy. The next one is I say conjugate of a complex number and say the function is conjugate. Now these functions I want to implement as the member functions of the class, or in other words, operation which I want on this particular data type. The very important part is how these functions will be declared and what will be basic functionality of this. In the last lecture, we saw that whenever any member function is used, we need one object, and that object is called calling object. For example, if I want to use this function, I need one object, and that object will be the calling object. That means to call any of the function, one of the object is positively involved, and that is known as the calling object. Now for designing of the class, what is basically required? Say, first of all I want this number, this function to be implemented, get or input of a complex number. Now input of a complex number needs one complex number. That means only one object is involved, and that object will be the calling object. Similarly, put number. If I want to print some complex number, I need one object, and positively that object will be the calling object, that is whose value is to be printed. This is important. This is for addition of two complex numbers. Now when two complex number will be added, there will be a resultant complex number, third number. That means in all, for using this function, three objects will be involved. Two objects which are given and the third which will be holding the result. That means I need three objects for this particular function. Now two values are given. I will be using those values as argument of this function, and no doubt the result will be stored in the third function, and I will be using the third function as a calling object. Now this is very important. Two objects I will be providing as arguments, that the two complex numbers which are given to me, And the third one, which will be the result, that I will be using as a calling object. The next function, if I say copy, now copy means I want to copy one complex number to another complex number. That means I need two objects. One object which is given to me and the second object which will be the result. Now the given object I will be using as a argument of this particular function, and the result will be stored in the calling object. The last one, that is a conjugate. Conjugate, as we know, a plus eta b is a complex number. The conjugate of the number will be a minus eta b. Now, two objects again are required. One which is given to me, I will be using as an argument, and the resultant function I will be using as the calling object. Now, from this discussion, this is very clear how many objects I need to implement a particular function. And one of them I will be using as a calling object, and other I can use as arguments of the function. Again, only one object is required, that will be the calling object. To print, only one complex number is required, that will be the calling object. Addition of two complex numbers, three complex numbers will be required, two I will be providing as argument, and the calling object will be used to hold the result. The next one is copying. Two objects will be required. One I will be providing as argument, and the result will be stored in the calling object. And conjugate. Conjugate, again two complex numbers will be required. One I will be providing, which is given to me, I will be providing as an argument, and the result will be stored in the calling object. Now, how all these things will be implemented, we will be considering the previous lecture, and in that framework I will be adjusting this particular class. No doubt, I will implement this in the form of a program in which a class will be declared, a class will be, the code for the class will be written, and then objects will be declared and used in the program. I will be using a menu driven program in which all these options will be there, and user can use as per the requirement. We will start with the program, how this program will be implemented. In any C++ program, first we need, that is the header files. These header files are required to use some of the library functions. Say the first one is conio.h. Now, conio.h file is needed for input-output operation or cin and cout. The next one more I can use to implement to use the function clear screen. Let it be include, this is iostream.h. Now this is iostream. In fact iostream.h, this is for input output, and this is console input output. This will be for the function getch and clear screen, etc. Now these two header files are required to use some of the built-in capabilities of the compiler. Now I say I will be declaring a class, and this class is for complex number. The first word class is this is a reserve word, and this is the name given to the new data type which I am going to implement, and that is, say, complex. Braces. Now the first part, private. I hope private members are those which can be used within the class or by the members of the class. So private. Data members I will be declaring as private. Say float. This is real part, and the another one is float, and that part is the second member, that is the imaginary part. Now this particular part is data member declaration of the class. Now say the next one is public. Public members are those which can be accessed within the class as well as outside the class. I want to declare all the member functions as the public. Now I will be giving the declaration of the member function here. As discussed, it will be as per the number of objects which will be involved in this particular process. As I said, get number, only one object is involved. So I won't be returning any value. If I don't want to return any value, the type of the function will be void. The next one is name. Name of this function is getNumber and braces. No argument is given, no value is returned. In this particular function, only one object will be involved, and that object will be the calling object. The next one is, say, void, and it is putNumber. PutNumber, this is another function which is to print the value of complex number. Now to print the value of complex number, only one object is involved. That is why no argument and no return type. The next one is addition. It is void, add, and in bracket I say complex, comma, complex. Now this declaration is very important. This particular is declaration of this function. This indicates the name of the function is add. We will be providing two complex number as the arguments. Now these will be the two complex number which are to be added. Now where will be the result? The result will be stored in the calling object. So three objects are involved, two as arguments and one is the calling object. The next one is, say, void, and this is copy, and one argument, and that is complex. Now this particular function will be having one complex number as input, and the result I will be storing in the calling object. Say the next one is void, conjugate, and the next one is complex, brackets. Now this is how the class is declared. Now this is a particular class that is for the complex number. This class is having two data members, and this class is having these 5 member functions. Now no doubt these functions can be as per the requirement of the application. Now the next step what we will be doing is how to define these functions. We will be defining these functions outside the class, and that will be with the help of scope resolution operator. Now how this will be done? I will be defining this first function. Say it is void. This is the type. Then class name, and the class name is complex. Then the scope resolution operator and the function name, that is getNumber. This is how the function, member function, is defined outside the class. This is class name and this is function name. This is indicating that this particular function belongs to the class complex. No doubt the code, I say C in the real part and C in the imaginary part. This is input of this complex number. Now similarly, the second function definition, it is void, complex, scope resolution operator, and the function name, that is putNumber. No doubt the statement, if I say C out, first is real part, and say my plus symbol I will be displaying, and then the imaginary part, and then ita will be displayed, and end of this function. Now these two functions are defined. Next, very important is the definition of the third function, and that is addition. Now for addition, two arguments we will be providing, and the result will be stored in the calling object. Say void, it is complex class name. Then it is scope resolution operator. I say add the function or two arguments. Say complex x, comma, and then another one is complex y. Now in this example, I will be adding x and y, and the result I will be storing in the calling object. Now the logic is very simple. When two complex numbers are added, real part is added to real and imaginary part is added to imaginary. The logic can be written very simple. Real is equal to x dot real plus y dot real, and similarly the imaginary part can be, that is x dot imaginary plus y dot imaginary, end of this logic. Interestingly, I used x.real. This is indicating the real part of object x. I used y.real, the real part of object y. I did not use anything with this. When I am not using anything, it is positively of the calling object. That means x and y objects will be added and the result will be stored in this calling object. I hope the next logics are very simple now. It is void. It is complex, the class name. The next one is copy. That is the function name. And one argument, say that argument is x. The logic is now x, I want to copy the value of x into the calling. It means the real part will be added to real. Real is equal to x dot real and imaginary is equal to x dot imaginary. Object x is copied to the calling object. No dot operator. This is indicating these are the two members of the calling object. The last function, and this function is conjugate. Say on the same with the same logic, on the similar lines, I can define this particular function. It is void. Void, that means no value is returned. Then the next one is complex. It is void. Then it is the class name, that is complex. Scope resolution operator, conjugate, and in bracket it is complex x. That means the calling function will be conjugate of x, and it is real is equal to x dot real and imaginary is equal to minus x dot imaginary, and end of this function. So I declared the class and I defined all the member functions of the class. All are defined outside the class. That is why the scope resolution operator is used with all this. Now the next step will be, I will be writing the program for this. The program in which this particular class will be used with the help of objects. So we will be declaring the objects and then using this particular class in that. Say, I want to make a menu driven program in which all these options will be given. Void, main. This is the main function. The execution of the program will start from this only. I will be declaring three objects, and objects are declared by giving the class name. This is complex. The object name, say C1, C2 and C3. These are the three objects which are there. Now menu driven program, I need one variable and that variable is for choice. I say integer variable choice. Say option 1 or option 2 or option 3 or option 4, whatever is. Now I want to clear the screen, CLR, SCR. Now this function, basically to use this function, I needed the file conio.h. Now this function has its prototype in basically conio.h. Now I want a loop for repetitive execution. Say it is while 1. Now one value is the true value. That means this loop will be repeated again and again because the condition I am giving is true. Now say I want to clear every time the loop is executed, I want to clear this particular value. So I will be using CLR, SCR within. No doubt this particular line becomes redundant. If I leave this, even thus the program will be working, because in while loop I am using clear screen. That is why with every repetitive step the old values will be cleared from the screen. Now I display the options. Say it is cout. Now cout, this is only a display statement. I say the option number 1, this is for addition of two complex numbers. And no doubt to change the line so that the next value is printed on the next line, I will use AND L. This is end of the line. It will be affecting the next C out statement. That will be going to be printed on the next line. Now say it is C out, it is say value 2. This is to copy one complex number to another and NL. Now these C out statements are basically only to display the options on the screen. It is the next one, C out. This is option number 3, which is to find conjugate of this particular number, and this is NL. And no doubt for breaking this particular logic, I say the option 0 is used. 0 option is used to exit from this particular loop. Right? So this is basically where I displayed all the options. The first is addition. Second is copying the one complex number to another. The next one is conjugate of a complex number. And no doubt the last option is for exit. After displaying all these options, I say what is the user's choice, and the user's choice is in the form of CH. Now user will be entering the choice in the form of CH. Now the process is very clear. If user says the choice is 1, that means it will be addition. If user says the choice is 2, it is copying one complex number to another. And if user says it is 3, it is conjugate. Now I will start with the first one. If choice is 1, say the user's choice is 1. Now what is required now? I need two complex numbers which are to be added, and result is to be stored in the third one. Now I need the input of the first number. Very simple. I have a object C1 and the member function get number. This get number will be called with the object C1. Values which we will be entering will be going to this object C1. Now I say C2 dot get number. The same I will be using with now C2. Now the two numbers are available with me. I will be adding these two numbers, and the result is to be stored in the third object C3. C3 dot add, in bracket it is C1 comma C2. Now this C1 and C2 will be added, and the result will be stored in the calling job. How? Because the member function which I gave, that was having two arguments x and y. This value C1 will be shifting to x, C2 will be shifting to y, x and y will be added, and the result was in calling object. It will be stored in C3. I want to print this C3, and the process is simple. C3 dot put number. The logic writing is very simple. I am not having any logic with me now. All the logic is implemented in the class. I am just writing input of the number, input of the second number. It is addition of the two numbers, and the result is stored in the third number. The next one, copy. I say if choice is 2, if choice is equal to 2, it is input of the number C1 dot get number. The next one is copy this number to another one, C2 dot copy, and the result is now how this is copied, because in the logic I gave that argument is to be copied into the calling object. Yes, this argument will be copied into the calling object, and I am printing the value of this calling object. Now the third option, and the third option is now, and that option is conjugate of the number. If choice is 3, if choice is equal to 3, again I want to input one number, that is C1 dot get number. I want conjugate of this number, say C2 dot conjugate. This is the same function name which I gave at the time of declaration and definition, and it is C1, and no doubt C2 dot put number. Now these were the three options. The first one, that is addition. The second one, that is for conjugate copy, and the third one, that is for conjugate. And now the last option which I will be giving, and that option is the option of exit. Yes, it is the option of exit. If choice is equal to 0, I want to exit from this, and the simple statement for coming out of the loop is break. This break statement will shift the control out of this get ch. I just want to hold the screen, that is why it is get ch. End of the while loop and end of the main program, right? Now the process is very simple. In this particular lecture, what we did is we designed a class. Now designing a class means we just thought of what will be the data members of the class, what will be the functions, what functionality we need from this particular class. The data members were real and imaginary part, and the functionality, that was input in the form of get number, output in the form of put number, and then addition of two complex number, copying one complex number to another number, and then conjugate of number. The data members will be decided, yes. The member function will be decided, yes. How many arguments will be there in those particular functions, and how the result will be transferred back. In all these functions, we use the object, one of the object as a calling object, and remaining we provide it in the form of argument. For example, in addition of two complex number, two numbers we gave as argument, and the result was stored in the calling object. In copy, two objects were required. One we gave as argument, and the another was the calling object. Conjugate, again, one number we gave as argument, the second was the result was in the calling object. Now, when the class was designed, then we declared the class, and that was the class complex. Then the data members, we declared them as private, and then the member functions. This declaration of data and member function in a single structure, this is known as encapsulation. And some of the part we declared as private, this particular concept is known as data hiding. So we use the concept of encapsulation, we use the concept of data hiding. Then we defined these functions. Now the function definition we gave after the class, outside the class, for which the scope resolution operator was required. Now these functions could be declared within the class. In that case, scope resolution operator was not required. But importantly, when we define the function within the class, those functions are considered as inline functions, and lot of restrictions are applied on those functions, like those cannot be more than few lines, we cannot use any loop, we cannot use any recursive concept in particular function. So most of the time we define these functions outside the class, and for that we use scope resolution operator. So designing the class was first, then we declared the class, then we defined the member function of the class, and last that was we use this in the main program. Now in main program, this line is basically the declaration of the objects. Now we declared three objects, and the objects are of the type complex. This variable I declared, this was only as a choice variable. We prepared a menu with the help of a loop. Because of the repetitive nature, the loop will be repeated again and again, and the menu will be displayed on the screen for with different options. So this is option number 1, 2 and 3. One was for addition of two complex number, the second was copy, and the third is conjugate. No doubt for coming out of the loop we use another option, and that was then option wise we input the number. Say addition, we needed two numbers, that is why we use c1.get number, c2.get number. These two were inputs, c1 and c2, and no doubt the addition, and that was c3.add c1 and c2. c1 and c2 were added, and the result was stored in this c3. And the next one is copy, and the next one was conjugate. And no doubt the option 0, That was for break. Now, this basically is abstraction of data. That is why this class is known as abstract data type. Thank you very much.